In this video, we're going to talk about the relationship between sine, cosine, and tangent. We're going to talk about it specifically when sine of an angle is equal to, so let's say sine of an angle A is equal to cosine of an angle B. So when will the functions sine and cosine be equal to each other? What inputs do I need to have for A and B, the angles where they will be equal to each other? So we spoke a lot about how the relationship between sine of A and B is sine of A is equal to sine of B when the measurement of angle A plus the measurement of angle B is equal to 90 degrees. So when A and B are complementary, that's when sine of A will be equal to cosine of B. So we see this in a scenario where if I draw a triangle ABC, actually let's make ABC, I'm going to draw it twice for us. All right, in one scenario, I'm going to put theta, the angle we're talking about and looking at angle A. And in the next scenario, I'm going to put our angle theta that we're talking about at B. So if I look here at my first problem, if I take the opposite side from A, we get the side CB, and this is my opposite side. If I take the hypotenuse of this triangle, the hypotenuse is side AB, here. So if we see this relationship, we can see that sine of the angle theta is equal to the opposite side, which is side CB, I'm going to call it line segment CB, over the hypotenuse, which is line segment AB. And now, instead of looking at angle A, let's look at angle B. And this time, we're going to take cosine of angle B. So instead of sine, we're going to take cosine. And let's see what happens. So in this scenario, we want the adjacent side. And the adjacent side here is CB. And then with cosine, it's adjacent over hypotenuse. So we're also going to want the hypotenuse, which again here is AB. So we're going to see that we get cosine of B is equal to the adjacent, which is side CB, line segment CB, over the hypotenuse, which is line segment AB. And if you notice, in these two scenarios, and let me actually just change my theta here to A, that way it's a little bit more obvious. But in both of these scenarios here, we'll see that the ratio for sine and the ratio for cosine are equal to each other when A and B are complementary. So in all right triangles, the two angles that are not the right angles, so A and B, will sum to 90, because in a triangle, all the angles sum to 180 degrees. So if we do 180 minus 90, those leftover two angles will always be equal to 90. So this relationship is always going to hold true in all right triangles, where the two angles that are not the 90-degree angle sum to 90, and their inputs, if you plug one into sine and one into cosine, they'll be equal to each other. So let's see some examples. So we talked in class about how the relationship of an angle, let's say cosine with angle 20, will be equal to sine of angle 70, because sine and cosine are equal to each other. So if you plug these into your calculator, let's see what we get for cosine of 20. If we plug cosine of 20 into our calculator, give me 1 minute, cosine of 20, we get 0.93969. And if we plug in sine of 70, if you try it out, again, you'll see we get 0.93969. So these angles will be equal to each other. So we can see it in other examples where if I draw a right triangle PLM, when will sine and cosine be equal to each other? So if I'm given sine of P, what other relationship will be equal to sine of P? And we'll see here that the two angles that sum to 90 are angle P, and if we add it with angle M, the other angle in my right triangle that's not 90 degrees. And we'll see here that sine of P will be equal to cosine of M. And we'll see this problem come up in multiple different ways, but again, it's when the angles sum to 90. So I'm going to show one more example of a common way that we see this. So if I'm given cosine 2x is equal to sine of 3x plus 5, what is the value of x? Now a lot of students make the mistake and say that 2x is equal to 3x plus 5. But that is not true. Cosine of 2x is equal to sine of 3x plus 5. The angles that we're plugging in, sine and cosine will be equal to each other if these angles are complementary. So actually we need to add them together and set them equal to 90 degrees, because when the inputs into sine and cosine are complementary and sum to 90 degrees, that is when the functions cosine and sine are equal to each other. So if I simplify and combine like terms and solve for x, we get x is equal to 13. And this is kind of one of the ways that we see it. So again, there are multiple ways we can see this relationship holding true. Not 13, sorry, 17. We see multiple ways we see this relationship holding true, but these are some of the most common problems we'll see.